Okay, so today we're here working on prerequisites for AP Calculus AB. We're going to start off with linear functions or models. Well, here's a little Far Side cartoon that I thought you might like. Abducted by an alien circus company, Professor Winters is forced to write linear algebra equations in the center ring. Okay, so first thing I want to talk about is this idea of increments. And so if we talk about increments, let's say we're missing a parenthesis right here. So if we talk about increments, we're talking about using the idea of delta. Delta is a Greek word, right? It's for the Greek letter in the alphabet. So if you see that, that's referred to as delta. So we often have delta in front of an x, so it just means the change in x. And then we have delta y is, of course, the change in y, right? So in this case, what we're going to do is look at delta x and delta y. And so with that, that's what we're talking about here. When we talk about increments, the delta x change is a step, like an incremental step that you take, or a delta y. So in talking about both of those, then we have delta x is then equal to negative 6. I'm going to start from the right. Negative 6 minus 8, which is then equal to negative 14. Here's our. And then we have delta y is equal to 1, start over here, minus 3. And remember, if you start from the right-hand point here, then you've got to also start with the x's there and the y's. So delta x and delta y starts from 1 minus 3, which is then equal to negative 2. So no, you guys are used to doing this. I just want to connect the notation using delta. Okay, so now moving forward, we have slope, and this is something that you guys know how to do, so take a moment and do this and we'll double check it. But we're going to use the point slope form, and I want you to get familiar with this because this is really a more convenient form because you don't have to solve for b. You can just get your equation right away. So we're going to use point slope form. Y minus y sub 0 is equal to m times the quantity x minus x sub 0, where you have the slope and you have the point x sub 0, y sub 0, that is any point on the line. So we have the slope in this case is 5, and x sub 0, y sub 0 is going to be your 0.23. So when we get this all put in there, it's scrolling. Okay, so when we get this all put in the equation, I'm going to use pink. So we have, I'm going to just block this off a little bit. So I'll put this in green. So we have y minus 3 is equal to the slope, which is 5, times the quantity x minus 2. So you have your equation done, and you don't have, if that's all you're being asked to do, write the equation maybe tangent to a graph, you've got your equation written. You can, of course, write this as y is equal to 5 times the quantity x minus 2 plus 3. And that would work also, and that's just one step in case you want to put it into a graphing calculator for some reason. Or if you finish it as y is equal to 5x minus 10 plus 3, which would be 5x then minus 7. And there would be your equation in slope-intercept form. But we're being asked to answer this as this one. Oops, something happened there. So here's our answer to the problem. Well, just to carry it a little bit further. Wow, I'm really having a hard time here. Okay, so go back, and interesting dilemma. I think I'm just going to square it up, and there you go. Okay, so there's your slope-intercept form of the equation, and that would be your answer right here. Okay. So now the vertical and horizontal lines sometimes causes problems for people. So what I did is I have a point on the graph. That's the point negative 3, 8, negative 3, 8. So what I'm going to do, just label that here in red, negative 3, 8. And it says a vertical line through AB has no slope, and its equation is x is equal to a. So think about this as x is a. And then it kind of clarifies things. So in this case, the x value has to be the same thing. So here we would say x is negative 3. That would be our, and if you see here, that would be our statement, and then we could, of course, convert it to x equals -3 for our equation. And then if you're going to graph it, you can just say, all right, it has the point -3, 0 here, and -3, let's say -9, -3, -9, just randomly picking a few points, and then checking to see that all 3 points exist on the same vertical line. Okay, where it makes a V down at the bottom of it. You remember the name, okay? Then one more with this. You can pause and take a look at this if you need to. Horizontal lines. So a horizontal line through AB has no slope, and its equation is y is equal to b. Find the equation of the horizontal line through the point -3, 8. Again, we have -3, 8 here. So now in this case, a horizontal line goes left to right, okay? Now in that case, the equation is y is equal to b. So in this case, y is 8. So that would lead me to the equation pretty quickly. Y must be 8 then, because it has to be 8 for all points that are on this line. So if y is 8, then I can go here to this point, 0, 8. Then I could go to this point, I don't know what it is, 7, 8. 7, 8. Again, picking random points here. But then drawing the line, I think I'm a little off the grid, but let me see if I can move it up a little bit. Okay, that's fine. Okay, and so in both cases, this is the equation y is equal to 8. All the y values are 8 on that line. And then going back to this equation, this graph, x is equal to -3 is the equation for that graph. No y for this graph, and no x's in the equation for the second graph. Okay, now one more with a line, and we're going to get the equation for a line in this case, is linear temperature conversion. So in this case, where you have linear temperature conversion, you've got to consider, if you want to find the linear equations converting Celsius temperatures to Fahrenheit temperatures, then you got to use freezing and boiling temperatures with this. So we're going to write the equation of a line. And with this, what's the temperature probably put a question in here. So if you want to find the linear equation for converting Celsius temperature to Fahrenheit, then we have to have our ordered pairs in terms of CF then. So C being Celsius and F being Fahrenheit. So our ordered pairs, writing them out, get a good color for that. So then that would mean our CF ordered pairs would then be, well, we know that freezing temperature is when the Celsius is 0, the freezing temperature is 32. And when the Celsius is 100, then the Fahrenheit is 212. So I don't think I have to tell you which one is which here. You see over here where you have the scale, just picking up the ordered pair here and here for that. So we start off when we get at the slope. So we have slope. We want to write an equation. So the equation I'm looking for, I'm just going to say very quickly, is this then going to be the Fahrenheit is equal to the slope times the Celsius plus b. If I want to end up with it solve for b, I could. Let me make this a little smaller then. Bump that up here. So what I'm going to do is use the 2 points first, and I get the slope. So the slope is 212 minus 32. Oops, 32. And then that is over 100 minus 0. So now I can go and simplify that, but I get 9/5 for the slope, right? And then I can go ahead and put it in point slope form, so it is easier. So I have f minus, and I'm going to use the point 0.32. So point, slope, here's the point, here's the slope, okay? So then I get f minus the y value, 32, is equal to 9/5 times the quantity x minus 0. Oh, not x. Beep. Well, I guess that wasn't going to stay for much longer. So this would be c minus 0. So then our equation is, we can easily add 32 to both sides and get f is equal to, of course, 9/5 c plus 32. And there you go, there you have it. Okay, so there's our equation. So pause if you need to look at that and double check your work. So now if we want to convert from Celsius, let me go like that, from 20 degrees Celsius to Fahrenheit and 95 degrees Fahrenheit to Celsius, we're going to use the equation that you see above there. And let's see. Okay, so 20 degrees Celsius, we're going to get the Fahrenheit. So we're going to say the Fahrenheit is equal to 9/5 times 20 degrees. I'm just going to write 20 plus 32. And then I'm going to use the same equation, but I'm going to say, I don't know if the purple's going to be bright enough. Let's try hot lime. So I've got 95 degrees. 95 is equal to 9/5 c plus 32. And that would be the way to solve for both of these. So in this case, the first one is easy because with the first one you have f is equal to, it would be 9 times 4, which is 36 plus 32. And you would get f is equal to, what do you get, 68? 68 degrees. So that would be the answer to the first question. And the next question, you have a little more work to do. So if I plug in, I could use, however, the alternative equation. So maybe we'll try that, where we have c is then equal to 5/9. We just convert the above equation that we see up here. 5/9 times the quantity 5/9 times the quantity f minus 32. So all I have to do is plug in there, and I get the Celsius is equal to 5/9 times, I have 95 minus 32, and running out a little bit of room there, I get the C is equal to, I think I get 95 minus 32, 35 degrees? I think I get 35 degrees for my final answer. Boom, boom, boom. So for the second one, C is equal to 35 degrees. Okay, so now the last one of these is where, if we want to know where is F equal to C, so I'll put the work down for this, but I think you can kind of get where this is. If I want to know the unique temperature that is the same in both scales, then we would take this F is equal to 9/5 C plus 32. And then if these two are equal, remember, two things that are equal to each other can be, one can be substituted for the other. So we have C is equal to then 9/5 C plus 32. And all you would have to do then is solve for C. You can multiply by 5/9, or 5, 5, and then combine like terms. You should get C, then in this last case, is equal to negative 40 degrees. Or just negative 40. Okay, that's part 1 of this video. I'm going to have another video out to complete this lesson, and we'll see you in a minute. We'll be talking about solving linear systems in that and an application.